When talking about isotopic distribution, which can be measured with mass spectrometry, it's important to use a magnitude that quantifies that isotopic distribution. This magnitude, in some cases, is called isotopic signature. The isotopic signature is a measure of how the distribution of isotopes is with respect to a standard. And it's this formula here that may be a little bit overwhelming at the first time around, but in this case, notice that we will always need a standard to measure the isotopic distribution, in this case of carbon-13 versus carbon-12. So we always need a standard, and that's what we'll put in the denominator, and we will have we will put this ratio of isotopes of the specific sample in the numerator. What does this mean? Let me give you an example in the case of isotopic distribution on Earth of carbon. We have said that different isotopes of carbon, for example, carbon-13, 12, 14, they behave chemically identical. However, because they have different masses, they may accumulate differently in different parts of our planet. For example, the amount of carbon-13 in the atmosphere is different than the amount of carbon-13 in the carbonates of the sediments or in the methane resources in geological accumulations or in terrestrial plants. So how is this number computed? This number is computed by taking a sample and calculating the distribution of carbon-12 and carbon-13 through mass spectrometry. One puts the ratio here and compares it with the standard, with whatever we chose the standard of this distribution is. So let's make sure that we know that there is a magnitude called isotopic signature that quantifies in one single number the isotopic distribution of a sample. A simple question would be, a very negative isotopic signature, does it mean that it has a lot or of carbon-12 or carbon-13? Let's try to prove the opposite. If this is positive, the only way to be positive is for this ratio to be larger than 1. You will only have a negative number of isotopic signature if this ratio, sample versus standard, is smaller than 1. If you have a ratio higher than 1, it means that the numerator is larger than the denominator. If your numerator is larger than the denominator, it means that you have a lot of carbon-13, or at least more than in the standard. Okay, so a positive isotopic signature means that there is a lot of carbon-13. A negative isotopic signature means that there is less carbon-13.